Hi, Andrew here. Today I would like to teach you how to use the graph to write an equation for the following rational function. So it turns out that we need to focus on two things. We need to focus on the intercepts and the asymptotes. All right. So remember the intercepts, there are two types. There's going to be an x-intercept and a y-intercept. The x-intercepts are going to be where the function crosses the x-axis or touches the x-axis. So it appears that this function will only have one x-intercept probably located right about there. All right, I'm assuming, that this is going to trail on and on and on forever, and it reaches some horizontal asymptote here at y is equal to 0. So the x-intercept I'm going to write in terms of its coordinate. Right, that looks like it's going to be, it looks like this is going by 1, 2, 3, 4, 5, 6, right? So it looks like 1, 0, 1, 0 for the x-intercept. And then the y-intercept, there should only be one. All right, and it looks like it's happening right about here. And that looks like it's about, it looks like negative a half, right? It looks like half, and then it goes 1, and then half, and 2, and half, and 3. All right, so I'm going to write that down now. So remember, it's going to be 0, the x comes first, and then the negative 1/2. All right, next thing I'm going to do is look at my asymptotes. So it turns out that I have two vertical asymptotes here. All right, I have a vertical asymptote. Remember, all vertical asymptotes have x equaling some constant value. And the constant value here is going to be negative 3 for that first one. And the constant value over here is going to be x is equal to 2. All right, so we have vertical asymptote. And we also have technically a horizontal asymptote here. And I'm going to write these functions down. So we have x is equal to negative 3 and x is equal to 2. And we also have a horizontal asymptote at y is equal to 0. Right? If you were to extend this on out, you could almost imagine that these two parts of the function never really are going to touch. Okay? So we have that horizontal asymptote. Anytime you have a horizontal asymptote at y is equal to 0, you know you're dealing with something called a bottom-heavy function. Okay, bottom-heavy. Now what that means is that the highest power of x in the denominator is going to be greater than the highest power of x in the numerator. And we're going to see that happen shortly. Because now what I'm going to start doing is I'm going to start finally writing the function. All right. Now we know that rational functions, they all have a formula that kind of looks like this. Right? You can write f of x here if you like. F of x is going to be some polynomial function in the numerator divided by some other polynomial function in the denominator. And you have to remember that the vertical asymptotes here will highlight the values that x just can never be. All right. We have a value of x that it just can never be. There is no value for this function here in this graph where x is negative 3. It just can't happen. So these vertical asymptotes, these x values will always give you some insight about the roots, or the, I should say factors maybe, of the denominator function. All right. So what we're going to do is you basically now are going to take, if you have an x is equal to negative 3, you're just going to plug in x plus 3. And then an x minus 2. So you're basically just kind of flopping these signs. The reason why you're flopping the signs is because if x is negative 3 and you plug it into now this factor I just created, this whole thing goes to 0. 0 times whatever the heck that is goes to 0. And you have now a problem, right? The denominator cannot be 0. And that's the whole point. It can't be 0. That's why you have those vertical asymptotes. All right? So that's that. Next, we're going to take a look at the numerator function. Now, for the numerator function, we're going to now talk about the x-intercept. Okay? So when we have now our x-intercept, whatever the x value is, you're going to basically do the same thing. Okay? Because you know something special about this, and you're basically saying that when x is equal to 1, okay, the function's value has to be 0. So, in order for this whole function to become 0, what does the numerator value have to be? It has to be 0, right? So it's the same idea as we talked about for the denominator, all right, where I'm going to write x, and then if this is going to be a positive value, then I'm going to write negative 1, right? So now if you plugged in 1 here, 1 minus 1 is 0, and then this whole thing goes to 0, and that's what it says it should be. The function's value should be 0. Okay, and that's it now. That's it, at the moment at least. Now, if you notice, the highest power of x in the numerator is going to be just x to the first. And then the highest power, if you were to FOIL this out, it becomes a quadratic, right? X squared. So that's a bottom-heavy function. That's why I have a horizontal asymptote there, y equals 0. All right, but there's nothing to really do with that. All right, so now what we need to do is we are going to look at the y-intercept, but before we do that, all right, I want you to look at the directions of these things. So there's two very important things we want to look at, all right? So what you're going to do is you're going to first focus on the vertical asymptotes. Now, what you have to do is you have to understand the behavior to the left side of one of those asymptotes and then just to the right side. Whenever they go in opposite directions like we have here, there's nothing to do to the factor that was produced by this vertical asymptote. In other words, there's nothing to do with this. Don't touch it, all right? But whenever you have them going in the same direction, let's say right across from each other on one of the asymptotes, that's when you got to do something. So you got to find that factor, all right, x minus 2, and what you have to do anytime it moves in the same direction, you got to square it, okay? That's the first thing. Now the second thing also is you have to really understand the behavior, all right, of these functions. So notice that I know this looks a little funky, all right, but doesn't that kind of look like a quadratic or a parabola, right? And do you notice how this parabola here, I just like saying that, parabola, do you notice how this parabola has an x-intercept here at 1, and you know that all functions of parabolas are going to then have a look like this, some squared thing to it, right? That's what a parabola looks like. So what I need to do is this is now the factor that correlates with this region of the graph. And since it's a parabola, we're going to have to square that as well. Okay? Now that we're all good with that, now we can finally move on to that y-intercept. So all we're going to do, in order to take this into account, I'm going to plug in a little constant here and I'm going to solve for it, okay? Now what this y-intercept says, and you always treat this one at the end, you're going to take this value, that's your y value, that's what you're going to plug in for f of x, so negative 1/2. And then whatever this is, that's a 0, you're going to plug it in everywhere you see x, okay? So now we're going to have the constant times then 0 minus 1 squared, all over then we're going to have 0 plus 3 times then 0 minus 2 squared. Let's try to simplify this now. So that's equal to c, and on the top you're going to have a positive 1, and this is going to work out to be a positive 4, right, because you're squaring it. And then positive 4 times 3 is going to be a positive 12. And now what you're going to do is just solve this for c. Okay, so whatever, since you got to get rid of the fraction, multiply it by its reciprocal on the right. Whatever you do on the right, you better do on the left. Okay, and now you're going to multiply these two things. So 12 times negative 1/2 is going to be negative 6. So the constant here is going to be negative 6. All right, and now what you do, go back to your original function and just plug in now a little negative 6. And that's now good to go. If you want to check yourself, take out your calculator. It's always a great idea to check your work. And now simply plug it in. So negative 6 times now, open parentheses, x minus 1, okay, squared, then divided by 2 parentheses now because I got to start being careful with what I'm plugging in, x plus 3. Hopefully, let's not talk too much so I don't screw something up by getting distracted. Square that, don't forget to square it, close the parentheses again and hit graph. And there it is, right? There's the function. So, hope you guys liked this video. Thanks so much for watching. I look forward to helping you with more problems. Check out our channel because we've got thousands of videos out there, and I want to help you with more. All right, not only math, but chemistry, physics as well. We have a whole lot of stuff coming. Stay tuned.